So this is question number 53 from 2022 paper. So it's AB matrix, and let it is A transpose which denote the A transpose of A, and U and V are column vectors with entries in real space such that U1 square plus U2 square equal to 1, and this is the V1 square plus V2 square plus V3 square is equal to 1. So here some conditions are given. AU, A transpose V, and we have to find the value of this. Now, first find what is AU. So, this AU will be U1 plus U2. So, this U1 into U2 minus U1 plus U2 is equal to root 2 root V. Root 2 V. Sorry, root 2 V is column vector V1, V2, V3. Okay. So from here we can get this U1 plus U2 is root 2 V1 minus U1 plus U2 is root 2 V3. U2 is equal to root 2 V2, right? So from here we can get U2. So U2 will be 1 by root 2 V1 plus V3, right? And U1 will be 1 by root 2 V1 minus V3. Okay. Now, if we do the transpose form, A transpose V. So here it will be, it is root 2U. Okay. So A transpose means 1 0 minus 1 1 1 1, right? And is given by U. U means it is V actually. So V1, V2, V3 is a root 2 of U1. Okay. So we can write it as V1, V2, V3. So now what will be this? V1 minus V3. Okay. And V1 plus V2 plus V3 is equal to this root 2 Uy root 2 U2. Okay. Now we have this V1 minus V3 is root 2 U1. Okay, so we know U1 1 by root 2 V1 minus V3, so it is equal, so you can see that is A transpose it is, so it is indeed U1 into 1 by root 2 V1 minus V3. Now another option is another equation will be V1 plus V2 plus V3 is equal to root 2 U2. Okay. Now V1 plus V2, V1 plus V3, you know, divided by root 2 will be U2, right? So we can write over here this V1 plus V3 is equal to root 2 U2 plus V2 equal to root 2 U2. So from here we can write this Vt is equal to 0. So if Vt equal to 0, then V1 plus 0 plus V3 is equal to 0. Okay. Is equal to, so this is V2 equal to 0. Now we know that U2 from here, so we can write this U2 is equal to root 2 V2 equal to 0, right? So V1 plus V3 is equal to 0. So we can write V1 is equal to minus of V3, or V3 equal to minus of V1. You can write it in this manner, right? Now if we do this, U1 square, we have the C in the, so we have these two conditions given. So U1 square, so here we were writing this in this manner, U1 square plus 0 is U2 is 0 equal to 1. So U1 is plus minus 1, right? So if we put this U1 over root 2, okay, so we have this U1 over here. So if we put the value over this, so we will get plus minus root 2 equal to V1 minus V3, right? And we know V3 is equal to minus V1, so twice of V1 is equal to plus minus 2. So V1 will be plus minus 1 by 2, okay, 2 by 2, 1 by 2. Now we have to calculate the value that it is given. So the value we have to calculate the mod of U1 plus 2 root 2 V1 mod. Okay. So here we will just put the values of U1. U1 is plus minus 1 plus 2 root 2 V1, so it is plus minus 1 by root 2. So here you can see that root 2 will cancel out. So plus minus 1 plus minus 2, so plus minus 3. So this inside mod, so we will take the value only 3. Okay, so the answer for this value is equal to 3. Okay. So question number 54, let f be in this closed interval 0 to pi in the real space be the function defined by fx in this range x equal to 0 to pi by 2, and another function for 0 pi by 2 x pi to pi by 2, pi by 2 to pi. So to find the value of 0 to pi fx dx, what is it will be equal? No. So now we will let's consider this equation in this range from x range to pi by 2 to pi. So if we took this equation like this, I1 is equal to integral of pi by 2 to pi x e to the power sin x dx. Okay. if we put this y equal to x pi minus 2, okay, so dy is equal to dx and x is equal to y plus pi by 2, right? So to change the limit from y x to y, so I have to do this. Now if we put so this x and y, now when x is equal to pi by 2, y will be 0. When x is equal to pi, y will be pi by 2. So from 0 to pi by 2 it will be, so we can write in the same manner that I1 is equal to, so we can write this integral as 0 to pi by 2 y plus pi by 2 e to the power sine pi by 2 plus y dy. Okay. Now we can do this. So transferring to this side, so e to the power sine pi by 2 plus y means cos y is in the second quadrant, cos pi. So pi by 2, if we take this in this manner, so pi by 2 integral of 0 to pi by 2 sine of what is sine, it will be cos y dy plus 0 to pi by 2 y of, so here it is e to the power cos y. So it is e to the power cos y dy plus pi by 2 from 0 to y e to the power cos y dy. Okay. So we can write it, so let's do the integration over here, so pi by 2 so here we can write this 0 to pi by 2. So if we write this cos of pi by 2 minus y dy, okay, if we do this plus 0 to pi by 2, so here is y, so if we put it in this manner, this y is pi by 2 minus y e to the power cos of pi by 2 minus y dy. Okay, so how can we write this? We know, now go to this basic idea of, so we know that from anything from 0 to a integral f of x dx, we can write it in this manner, is 0 to a f of a minus x dx. So we can write it in this manner. So this is the form of this. Okay, so here we can mention after this step, so pi by 2 it will be 0 to pi by 2 e to the power sine, will be sine x dx, right, plus of 0 to pi by 2, so it will be pi by 2 minus x e to the power sine of x, e to the power sine of x dx. Okay, so we can write it in this manner. So pi by 2 is there, so pi minus x, so integral 0 to pi by 2 pi minus x e to the power a sine x dx, or we can write it in this manner. So let's just select the question. So our first expression for this fx is x minus pi e to the power sine x when x is from 0 to pi by 2. So we can similarly do the same thing, that is minus of 0 to pi by 2 x minus pi e to the power sine x dx. So this we can consider as I2, so we can write it minus of I2. So we will find that I1 plus I2 is equal to 0. So we have to find 0 to pi f of x dx. So now write the full equation from 0 to pi. Okay. So we have to find the integral from, so this is the from 0 to pi by 2 and the from pi by 2 to pi. So here it will be I1 plus I2. Now we will do this 0 to pi by 2. 0 to pi by 2 x minus pi e to the power sine x dx plus pi by 2 to pi x of e to the power sine x plus 4 by pi dx. Okay. So here it is the I2 plus I1, this part, plus pi by 2 to pi 4 by pi dx. Okay, so this remaining the integral will be, so 4 by pi x of pi to pi by 2. So from here we will find that 4 by pi is there and pi by 2, so it will be 2. Okay. So the value of this integral is equal to 2. Two significant places. So we have just a whole number, so we can write it. This question number 54.